Sure, yeah. Okay, so I just wanted to kind of give you a minute to look over your warm-up, make sure it looks the way it was supposed to, and keep in mind the warm-up is usually just related to the previous lesson. So I usually tie it in with homework because you're looking at pretty much those exact same problems while you're checking your homework. So if you bailed out on the homework assignment last night, which 8 of you did, if you bailed out on the homework assignment last night, you get kind of a chance in the warm-up to look over those types of problems again. So if you take a look at our little warm-up here today, you had to evaluate sine, cosine, and tangent for those two radian angle measures. So for instance, on part A, you're like, hey, 11 pi over 4, that looks familiar. We did one really similar yesterday, and I think even the day before. The reference angle for that guy is 3 pi over 4, because 8 pi over 4 is 2 pi. I'm sorry, the angle, the coterminal angle is 3 pi over 4. The reference angle is pi over 4, sorry. So you see that the square root of 2 over 2, square root of 2 over 2 comes into play. And then when you divide out those two values, since this guy is in quadrant 2, you have a positive sine value but a negative cosine value. When you divide those out, you get -1. And then that looked good as I walked around. You guys were okay with that. And then as I walked around and looked at part B, you had -1/2 for your sine value. Your cosine value is the square root of 3 over 2. And then tangent is -√3 over 3. What's up, Scout? Okay. Okay. Yeah, that's not right. Yeah, and when you say I subtracted it, like I don't necessarily know what your it is, so I don't know like how you got 25 over 6. -13 pi over 6. Okay. So I know what you did now. So it sounded like you subtracted 2 pi and you didn't actually add, because when you add 2 pi, you're adding 12 pi over 6. But how did you get, so you got 25 by doing -13 minus 12. Yeah, you should have added it, yes. So thank you for clarifying. That's what happened. Hey, I do what I can. All right, any other questions about the warm-up? Okay, and then this last little slide here is just a little review of your identities. So I do want you to check those. You're going to be using them today. You're going to be referring back to this chart if they're not completely blank, banked in your memory there. So I do want you to just take a minute and look those over, make sure they're accurate in your notes so that you have them to look at if you need them. Those should be in your memory. What you're going to see a lot of in this section is that this chapter in a lot of ways mimics what we did in 1.3. So now what are we doing? We're now doing identities with any trig function value. And any angle on, period really. So we're finding trig function values of any angle. I'm trying to multitask, sorry. Yes, Clay. Sorry. We're trying to find trig function values for any angle, not just angles on the circle, and today we do that with identities. All right, so with that, woo, that's my completed slideshow, sorry. Pull up the right one here. When I taught this lesson for trig functions of angles that were on the unit circle, I taught this in 2 steps. Step 1, you have to identify the identity you want to use. Usually you do that based on 2 criterion. The first is, what do you know about the problem? And then the second is, what do you not know about the problem? So in example 1, what I have here is that the sine of theta is a third. So what I know about the problem is the sine value. In part A, I am asked to identify the cosine value. And we're going to do that via identities today. Please keep in mind that you always want to watch your sign. That's really important in this chapter. And what I mean by that is your plus or your minus. That's kind of why they give you this piece of information in the first place. So that's why they give you information about the quadrant in the first place. They don't type that in there for decoration. That is actually part of the clues that you have to solve for cosine in this problem. So we're given that theta itself is in quadrant 2 and that the sine value is a third. Step 1, we choose an identity that relates sine to cosine. Step 2, you substitute what you know, solve for what you don't. Step 3, there's a third step when we do it today. You have to attach plus or minus in front of your answer. So it's the same step 3 as yesterday. We had to figure out if it was plus or minus. All right, step 1, you have your identities. You just went over them. They're on your chart. If you need to look them up right now, you can. We are trying to find cosine given sine. So essentially what we have to do is identify, one or more identities that it relates, sine and cosine. Anybody have any ideas? Go ahead, Katie. Sure. That definitely does the trick. Did anybody come up with another one? What do you think, Clay? What's that? You can actually do your x over r, y over r business, draw this out in quadrant 2. You can get around using identities, period, for these problems. But in this section, so you could do what we did in the past to solve for cosine, secant, tangent. You could do that y over r, x over r business. But in this section, they want us to use identities to verify those trig function values. So it's a slightly different way of doing the problem, Clay. But you're right, if you did it your way, you'd still get the answer. What's up, Scout? Correct. Yes, that is also true. Now, one of these works out to be a little nicer than the other. True story. So what I'm going to go ahead and do right now is take what I'm given about the problem. In other words, that the sine is 1/3, and I'm going to fill that into both of these things where I see sine. Okay? So I'm going to replace or substitute the value of 1/3 in for sine because I'm given that information. So now here I have sine squared theta plus cosine squared theta equals 1. I'm going to go ahead and plug in my sine value. And then in addition in this problem, I'm also going to try to use the one Scout mentioned. So I'm going to do 1/3 divided by cosine. And I said this before when we worked with identities, you really can't be afraid to make a mistake. If you pick the wrong identity, you just got to try another one. So right now, looking at these two identity equations, one of them is a little easier to solve than the other. Actually, the other one can't be solved. Which one, moving forward, would you then continue to work with? Would you work with Katie's or would you work with Scout's? In other words, would you work with the Pythagorean identity to solve for cosine, or would you try to work with tan to solve for cosine? Scout really likes hers. What do you think, Emily? The Pythagorean identity. You can't solve, she's so sad right now, she's got the pouty lip. If you look at this right now, there are two unknowns in one equation. You can't solve that. How would you? If you want to get cosine by itself, like tan is always going to be in there. We need to get cosine to be a number. What's up? Okay. So this one, unfortunately, doesn't work. But you can use it in part B. So hold that thought, Scout. We're going to come back to you. So I'll copy that again a little later. So yeah, Emily, you were right. I have to go ahead and use the Pythagorean identity now to go ahead and solve for cosine. So that's what I'm going to do. I'm going to square 1/3. You know how to square a fraction. You square the top, you square the bottom. So this will be 1/9 plus cosine squared theta equals 1. And then to get cosine squared by itself, you have to like peel off those layers to isolate cosine. You know what you have to do to both sides? Subtract 1/9. So we have cosine squared theta. And then you have 1 minus 1/9. That's 9 over 9 minus 1 over 9. 1 whole take away 1/9 is 8/9. And then I'm not quite done. The problem asked me to solve for cosine, not cosine squared. So what do you think? Square root it. Good, Roya. So we have cosine theta equals plus or minus, and then we have the square root of 8/9. And really, you never leave me something that looks like that. So we have to simplify a little further. You might remember from your Algebra 2 class or your college algebra class, you know, you can square root the top and square root the bottom using the quotient property for radicals. And then square root of 8, that's 2 root 2. Square root of 9 is 3. Okay, but I have a question for you. I prefaced this problem with, watch your plus or minus. Do you see that there? You can really only have one answer for cosine in these problems. They do give us an additional piece of information in the problem, and I said you can't ignore it. What they're telling us right now is that our angle is supposed to be in quadrant 2. They give you that information so that you can start to make a decision about that plus minus right there. So what I'm thinking about right now is quadrant 2 in my all students take classes. They're saying this angle is in quadrant 2, so that's right there. So I have to decide a couple things. What that S stand for in quadrant 2? And then how does that affect my answer? What does that S stand for in quadrant 2? Go ahead, Scout. Yes. Which means that sine is the positive value in quadrant 2. Which makes cosine what? Negative. So, woo, the answer to this problem is actually negative 2 root 2 over 3. Questions about that? All right, let's do it again. This time, we know what cosine is and we know what sine is. I have to find tangent. So I know sine and cosine, and I have to find tangent. Scout, what identity would we use? Uh-huh. Nice job. And I actually have those numbers already, so I would not want to calculate them again. Sine, I think, was a third. Cosine we came up with was negative 2 root 2 over 3. And that looks like a hot mess. So let's simplify that a little bit. I guess my question is, how do you simplify that? Go ahead, George. Flip which one? Yes, you multiply by the reciprocal of the denominator. Good, George. I'm going to cross cancel these 3's because I can. And you have negative 1 over 2 root 2. Am I done with that? No, why not, George? Yeah. What would you do, Roya? Yeah. So we have negative 1 times the square root of 2. That's the square root of 2. You can make it negative. And then we have 2 times the square root of 2 squared, which is 2 times 2, or 4. That's my answer. The sign was actually figured out for me, negative, because I was dividing two known values. And it makes sense in quadrant 2, tangent's negative, so kind of works out. It's a negative answer. Questions about that? Okay, let's do one more together, and then I'll cut you loose on the last one for a little bit of independent practice. All right, so in example 2, it says find the indicated trigonometric value in the specified quadrant. So it says let theta be an angle in quadrant 4 such that our sine is -3/5, and we're asked to find cosine. Now, keep in mind that Clay was just doing an assignment from, some makeup work, and he said, can't you just use your y over r, x over r, y over x business to figure all this out? Fact, he is correct. You could, but today's topic is using identities to solve this. So if you take a look at part A, what I have here is information that tells me my angle is in quadrant 4, and I'm given the sine value, and I'm asked to find cosine. What do you think, D? Which identity are you going to pick? We could try that. You could try that. So let's do D's way. So here's you, D. Carrying along, happy as ever. Just so excited to be doing your trig homework tonight. And you're like, I'll just sub in my sine value -3/5 there, and then I'm going to go to solve for cosine. Oh, man. One equation, 2 unknowns. You get nowhere. So then what do you do? Yes, good girl. You would try another identity, the one you just chose. And then you're going to sub this guy in for sine, right? What's up, Clay? Oh, yeah, I forgot. Sorry. So you have -3/5 squared up. And then now we're still trying to solve for cosine there. Remember when you square a fraction, you square the top and you square the bottom. So squaring 3, you get 9. Squaring 5, you get 25. I do need to solve for cosine. So who did I talk to? Imani, what would you do to both sides? You're ahead of me. It's all right. Yeah, good girl. So what we have here is cosine squared theta equals 1 minus 9 over 25. So that's like 25 over 25. Take away 9 over 25. So nice, though. You get 16 over 25. And you're like, ka-ching, those are perfect squares, Mrs. Lucas. That's awesome. So square rooting both sides actually really wasn't too bad. However, in square rooting both sides, you always get the plus or minus. So we're going to have a chat about that. So you have plus or minus 4/5. So we go back to that information to make our decision about the quadrant. This is in quadrant 4. Quadrant 4. So drawing it out, all students take classes. Down here is quadrant 4. So I have to ask myself, should cosine be positive or negative in quadrant 4? This is step 3. This is our last thing we have to do. Go ahead, Emily. Yes, it is positive for certain. The C in quadrant 4 means that cosine is positive, which means my answer here is positive. There it is. Okay, you ready to try one on your own? It's our conclusion problem for the day. If you finish quickly, you can definitely take a look at your homework assignment for tonight. Your one last problem there. And I think I already uploaded the slide to Blackboard for you. So you can take a look at that.